Hey stat students, so today we're going to just kind of more formally write out and talk about what type 1 and type 2 errors are. It's really important to understand that every single hypothesis test is definitely going to have room for error. And it's important that we understand what those errors are so that we can limit them, or we can kind of take the consequences into accountability. All right, so the first type of error is type 1 error. This is also known as your false positive, if you like to think of it that way. And a type 1 error is when we are rejecting the null when the null is actually true. Okay? And so one thing to know is that the probability of a type 1 error, is denoted by alpha. We've seen alpha before. Alpha was our level of significance, if you remember. That was our level of significance that we use for confidence intervals. So it's the same alpha that we're talking about here. That's our probability of a type 1 error, okay? So for example, if we had a test with an alpha level of 0.01, it's said to have a level of significance of 0.01, or you can also see the language that's called a 0.01 test, okay? So our alpha value, if you remember from way back when, a couple weeks ago, we had a normal curve. We had a confidence interval here, where let's say we said, I don't know, we're 95% confident. Well, remember, alpha is that area on the outside added together. This is alpha over 2, and this is alpha over 2. So if the alpha level is 0.05, that means we have a confidence level of 95%. That was just a little flashback, okay? That is the same exact alpha level that we're using now. We're saying that now this alpha level is the area or the amount of type 1 error that is allowed or occurring within the sample. All right, our most common alpha values are 0.01, 0.05, and 0.10, corresponding to a 99%, a 95%, and a 90% confidence interval. All right, type 2 error, also known as a false positive. Okay, this is when we're failing to reject the null. When the null is actually false. So we fail to reject the null when we should reject the null. The probability of a type 2 error is denoted by the Greek letter beta. And later on in this unit, we're going to talk about the relationship between alpha and beta more specifically. But now, it's just kind of important. These are important things for you to know about how alpha and beta relate to each other, how type 1 and type 2 error relate to each other when we're running a test. Here's important things to know. As alpha gets bigger, beta gets smaller. And vice versa. As beta gets bigger, alpha gets smaller. So type 1 and type 2 errors are inversely related. If I have more type 2 error, I have less type 1 error. If I have more type 1 error, I have less type 2 error, okay? An ideal test procedure would result in an alpha value of 0, of course, and beta 0 too. But the only way to do this is if you had an entire population, okay? That's if you have the population, then there's no room for error because you're counting every single person. However, since we base our information off a sample, our conclusion off a sample, this will never happen. There will always be a chance for error. And that's why we just want to be aware of that. We want to know that can happen, and we want to know what the error is, and we want to be smart enough to limit an error that may be more devastating. So as the investigator, we must carefully balance the consequences of type 1 and type 2 error. All right, so what if a type 1 error results in a very serious consequence, okay? So we would choose a smaller alpha value, okay? So if a type 1 error had a more serious consequence than a type 2 error, then we would choose the smallest alpha value we can so that this area is very limited, that type 1 error. In doing so, we're going to increase the probability of a type 2 error, but we can weigh out the differences between the two to decide which alpha value is more appropriate. What if a type 2 error resulted in serious consequences? We would choose a larger alpha value, okay? So then we would increase the probability of a type 1 error occurring, not a type 2 error, and we could avoid that error as much as possible. We know errors are going to occur. They always are going to occur, but we can just reduce which type of error based off of the alpha value that we choose, okay? That's really all there is today to know. You need to just make sure you're walking away, you know on the back of your hand what a type 1 error is, you know what a type 2 error is, and you know how type 1 and type 2 error are related. This is important because going forward into confidence intervals, confidence intervals too, but testing along with confidence intervals, we want to be able to make informed decisions, okay? We don't want to just be robots who crunch numbers out and produce things. We want to be able to explain why we choose something, back it up, report meaningful data, okay? All right, you guys have 2 little examples below that I trust and believe you can handle. So example 1 and example 2, go ahead and complete these and we will go over them on Friday together, okay? So on Friday together, we're gonna learn a new lesson. We'll go over these 2 and you'll have a little bit of practice on this and the new stuff that you learned. So have a wonderful Wednesday and I will see you on Friday.